Hello students, welcome back. Now we are going to start our discussion on FPGA implementation, and the first thing is the constraints file generation. So in this video we are going to talk about that what is a constraint file, what is written, what is defined in a constraint file, and how do we map our design source ports with the constraint file. So let us get started. So first of all, we should know what is a constraint file. There are certain codes and names and numbers which are allocated and printed on the FPGA for different pins, buttons, switches, LEDs and all. That means every component, every port on the FPGA has a unique name or code. Now, these numbers are also given for accessories which are called peripheral modules. We can connect additional components through these P mode pins. So all of them have these unique codes. What we need to do, we need to define the mapping of our Verilog code ports with these unique codes on the FPGA. A constraint file is needed to map those things. So a constraint file will tell the system that if my Verilog code is requiring 3 buttons and 2 LEDs, then which 3 buttons and which 2 LEDs should be used on a particular FPGA board. And that is the constraint it is applying, and this is the reason it is called a constraints file. So in a constraint file, we are going to define the mode of connection for every component, whether it will be input or output. We will also define the operating voltage for every component, whether it will operate at 3.3 or 1.8 or any other voltage. We need to have the declaration only for the required components, because there are a lot of components on FPGA. We don't need to declare for unnecessary components. Files are saved with the extension .xdc, and we have to take care that in our Vivado project only one XDC file is active. We can have as many as we want, but we should disable all others and only keep one file as our active file. So how do we create a constraints file? So first of all, every FPGA board has its own template for the XDC files. The best practice is we go to the website, download the file and then use it. You can also write your own file, but the best practice will be that we take the template, the raw file from the manufacturer website, and then we use it. This file which is downloaded from the website is going to have all the components commented. We will just uncomment the required components and the required ports, and then the remaining ports and the components will remain commented. That means they will not be used by our FPGA. So now we are going to have our first constraint file creation. We will do it for a very simple program that is half adder and using basis 3 board. I am going to use basis 3 FPGA board, and that is manufactured by Digilent in association with Xilinx. So we go to Xilinx University program website. We'll share the link with you. And when you scroll down, here you have professors and teachers section. You can go to Xilinx University program student area, and here you have free available training sources by Xilinx. Then you go to course material, and here you have the HDL based design for Nexus and Basis, both of them. and this is the master XDC file that we need. So this is the file. We right click and say open in new tab, and here you can see that all the lines are starting with hash. That means they are commented. It's a long file which defines the connection for every port, every component of our basis 3 board. Now what should we do with this? All we have to do is we can just copy this file or just save it anywhere, and Control A, Control C, we can copy this, and now we will go to Vivado and check that how to use it. So we are back in our Vivado project. We are going to click on add sources and add or create constraints. Then we go next and we will say create file, and I am saying half adder using data flow and basis 3 board. This is the file name, and we say OK and we finish. Now where is that file? We scroll down. These are our design sources. Then we have constraint sources and simulation. You can see in the constraint I have 3 files. These 2 were already created. This is the one which we have just created, and we double click on this. It is a blank file. Now we had copied the content of the XDC file, and we will simply paste it here. Now we can see that all the lines are commented here. So how do we map our half adder with this constraint file? Before we do that, first thing that you have to make sure that your project part is basis 3. How do we select that? Click on the name and then go to choose a device. When you have board with you, you can look at the cover and read the part number. I will show that in the hardware demo. So here we go to general purpose, RTX CPG 236 -1 and with a speed of 35. This is the board that we have, which is called basis 3. So whichever board you take, please make sure that first of all your project device is the same board. We have applied the settings and we click on OK. So settings are being applied, and then we will be back to the project summary. So now you can see that this is the project part and we are fine with this. Now open your design source for which you want to write the constraint file. So here I have half adder using gate level modeling, and we need to very carefully read the port names: small a, small b, sum and carry. So how do we work on this? We will say I am going to take 2 slide switches. One of them will be A, one of them will be B. And I will use 2 LEDs to display sum and carry. So now we come to our constraint file. So here you can see the first thing is clock signal. We don't need clock. The second is switches. We need switches. There are 16 switches, SW0 to SW15. You can use any 2. How to use them? Uncomment these 2 lines. These 2 lines belong to one switch. So now what are we defining here? We are saying set property of switch number V17. This will be written on the FPGA board. It is a package pin. It is having input output standard with voltage of 3.3. It is going to work on CMOS technology and voltage is 3.3. Now SW of 0 is the port name. Very carefully we will delete everything inside the curly brackets and we will write our Verilog port name, and that is A. So same we are going to do here, and inside the curly bracket we write our port name, that is A. In both the lines we will write the same thing. These two lines define the property of one switch. Now I am going to use one more switch, and here I am going to replace SW of 1 with B and SW of 1 with B. So two switches are used. Scroll down and we come to LEDs. There are again 16 LEDs. We can use any two of them. So we use first two. So here I uncomment the first two. We are going to use the first one as our sum. So we write sum here, and we are going to use the next one as carry. So two lines for each port. That's all we have to do. Do not touch or uncomment any other line, and if you want, in your constraint file you can use only these 8 lines. You can delete everything else. Now we can just save it, and we will also make sure that our top module is half adder underscore gate, for which we are writing this constraint file. And we will also go to the simulation sources, and there also we will make sure that we are selecting the same file as our top module. So students, now we know that how to write one constraint file, but we still need to take a few more steps before we can implement everything on FPGA. So the next steps that are there, they are synthesis and implementation. We are going to talk about these in our next video. Keep learning. Thank you.